Let us start the topics in our lesson of heat. In this lesson, we will deal about what is heat, what is heat, and what is meant by temperature also. Basically, heat means heat is a form of energy which transfers from one body to another body. Later, we will see what is the reason of flow of heat from one body to another body. It means that conduction of heat. Conduction of heat depends on, that means conduction of heat means it is the ability of flow of heat is called conduction of heat. Depending upon this topic, we will classify the given bodies are of two types. First one, good conductors of heat, and second one as bad or poor conductors of heat. Okay, basically we will say good conductors of heat are nothing but all metals, and remaining which falls under non-metals or plastic, they are poor conductors of heat. So that is about conduction of heat. Next we will deal about on which factor does the flow of heat depends. It is actually temperature. First of all, let me tell me about temperature. What is meant by temperature? We will deal here. The traditional definition of temperature is the degree of hotness or coldness of a body. It's a traditional definition. If you want to know the actual meaning, we will cover that one also in our topic. Okay. So the flow of heat depends on, next one, flow of heat or passage of heat flow depends on which quantity. We will deal, the answer for this question is like temperature. Temperature difference. So temperature difference is the deciding factor for the passage of heat from one body to another body. Next we will deal about two types of contacts. Types of contacts are of two types. A physical contact, first one, and second one, thermal contact. Okay. And next one, we will deal about, does the heat flows in all conditions? What mean? It means that do heat flow in all the conditions? The answer is no. The heat do not conduct between the bodies or among the bodies in all situations. And the concept we will deal about regarding this one is nothing but thermal equilibrium. So thermal equilibrium means it is the common temperature at which two or more bodies agree such that they do not exchange any kind of heat among them. Okay. So we deal about thermal equilibrium. Thermal equilibrium means it is the state at which there is no flow of heat between among the bodies. Next we will deal about how is temperature is different from heat. Later we will see the working of thermometer. How does thermometer works? Basically it works on the principle of thermal equilibrium. It works on the principle of thermal equilibrium. And the recording also done by the thermometer to show the thermal equilibrium of the bodies. Next we will deal about units of heat, both the SI unit and CS unit. The SI unit of heat is joules, and the CGS units are like calories. And we will see the relation between these two also. Later we will deal about types of temperature scales. Types of temperature scales. So these temperature scales are of three types: Celsius scale, second one Fahrenheit scale, third one Kelvin scale. So we will deal about these three kinds of scales. The next we will deal about relation between average kinetic energy, and absolute temperature. Absolute temperature means it is nothing but the scale of, it is the reading of the scale of Kelvin scale. Kelvin scale temperature will be treated as absolute temperature. So we deal about types of scales. Next we will deal about what is meant by specific heat. Specific heat means, our complete name is specific heat capacity. Before this topic, we will deal about what is heat capacity. So heat capacity means it is the ability of a body to withstand heat without rising the temperature. And specific heat capacity means it is a bulk phenomena, and this is a molecular phenomena. Okay, and we will deal about in specific heat capacity concept. How does the specific heat capacity depends on nature of substance. It means that even though if you take two different bodies of same mass and same quantity, and if you provide same amount of heat, they do not have same heat properties. That means they have different standards of withstanding the heat for different rise in temperature. So that is about specific heat capacity. And we will deal about the formula related to specific heat capacity. The formula is nothing but delta Q is equal to ms delta T. Okay, let us see the parameters in the formula. Delta Q means rise in heat, rise in heat. M is mass of substance to which we will provide the heat. S is known as specific heat capacity. Specific heat capacity. Okay. And delta theta or delta T is nothing but rise or fall in heat. It could be either rise in temperature or fall in temperature. If it is a positive means we can see it is rise in temperature. If it is a negative means we will call it by the name of fall in temperature. So that is about specific heat. And in the specific heat itself, specific heat capacity concept, we will see what is the relation between specific heat and temperature. Okay, if you modify this formula, you will get S is equal to 1 by M delta Q by delta T. So by correlating the formula, the two terms, S is inversely proportional to delta T. It means that a body which is having a high specific heat will have low rise in temperature and vice versa. And if a body having low specific heat means it will have more rise in temperature. So that is about specific heat. And next we will see about why different bodies, a question like why different bodies have different specific heats. The reason for this one is internal energy concept. We will see internal energy is a combination of two types of energies, named as internal kinetic energy and internal potential energy. So potential energy is not the reason for different bodies having different specific heats. The reason is here we have three kinds of kinetic energies known as translatory kinetic energy, rotatory kinetic energy and vibratory kinetic energy. Translatory kinetic energy could be called by the name of linear kinetic energy. So linear kinetic energy is the reason for different bodies having different specific heats. So the sharing of energy between among bodies will be differ in different bodies, hence the specific heat is different. Specific heat only. In specific heat capacity, we see some applications of specific heat. What are the applications? If you take a watermelon out of fridge, it will retains its heat or coldness. Why? Because water has high specific heat. So we will see the applications like why watermelon retains its coldness whenever you take it out of fridge. This is because of watermelon is having water. Water has high specific heat. Next we will see the samosa ingredients. Samosa ingredients also, that means curry inside the samosa is also having high specific heat. Okay. Next we will deal about an important question related to the concept of specific heat. It is determining or finding specific heat capacity of solids known as lead shots. So this one is an important question related to our specific heat concept. Next we will deal about another important topic, which is an application of thermal equilibrium concept. Application of thermal equilibrium concept, and the concept is principle of mixtures. Principle of method of mixture. Okay, this concept is nothing but the application of law of conservation of energy. It's an application of law of conservation of energy. What is the principle of law of conservation of energy? Energy is neither be created nor be destroyed, but you can convert it from one form to another form, or from one format of state of energy to other format of state of energy, such that the total energy is always constant. That means you are not supposed to create energy and you are not supposed to destroy energy. Only you can utilize the energy from one form to another form. So, by applying this concept to the thermal equilibrium concept, which is nothing but principle of method of mixtures, it is basically for two bodies you can apply this formula, or for three bodies you can apply this formula. It is like in the textbook it is given for two bodies. Q is represented for heat. Heat lost by hot body is nothing but equal to heat gained by cold body, such that the total energy is constant here. So this is about specific heat and the concept of principle of method of mixtures. Okay, by utilizing this formula, finally if you take two bodies having, in textbook it is given only for two bodies which are having same specific heat. That means if two bodies having same specific heat, then the final temperature or thermal equilibrium temperature after the exchange of heat, concept of thermal equilibrium, the final temperature, that is the thermal equilibrium temperature of method of mixtures, is nothing but M1 T1 plus M2 T2 divided by M1 plus M2. This is the formula for two bodies. If you apply for three bodies, plus M3 T2 M3 T3 divided by M3 will come here, but this formula is valid only if two bodies are having same specific heat. That means same nature, liquids or solids could be taken this formula. And we can generalize, this is not in the textbook, I am saying we will derive it. But if two bodies, what happens if two or more bodies having different specific heat? Then you are not supposed to use this formula. We will use this formula M1 S1 T1 plus M2 S2 T2 divided by M1 S1 plus M2 S2. We can use this formula. This is a formula could be applied for any kind of bodies. Okay. Next we will deal about the concept of evaporation. Okay, what is meant by evaporation? Evaporation is the phenomena in which the given liquid will escape from the surface. Say for suppose, if I take a beaker of spirit here, when you keep it below a running fan, what happens? After some time, the spirit will escape from the given dish. This is because of the concept of evaporation. So evaporation is a surface phenomenon. It is a surface phenomenon. Okay, and the factors affecting this evaporation are surface area, temperature, and third one, nature of liquid. So depending upon these three factors, the rate of or the speed of evaporation depends. So what is meant by evaporation? The phenomena, escaping phenomena, of a liquid from its surface is called evaporation, and this process of evaporation will not depend upon temperature. So it can happen at any temperature. So this concept of evaporation can happen at any temperature. So next we will see the applications related to evaporation. The basic application is sweating of human body. Why do we get sweat? Because we do most of our work in the format of heat and work. So when do we do certain amount of work, the work will produce a proportionate amount of heat, and this heat will make the temperature of skin high. It will increase skin temperature. So to make the skin cool, our sweat glands will have a water-like structure, which is nothing but liquid water. So these sweat pores will give out water. Sweat pores will give up sweat to cool down our body, to cool down our skin. So this is one of the application of evaporation. Okay, we'll about the reverse concept of evaporation known as condensation. Okay, condensation means if you take evaporation once, in evaporation process, liquid will be a liquid phase will be converted into gas, a gaseous phase. This is the phenomena happen in evaporation. Okay. Well, coming to condensation, condensation is a reverse process in which gas will be converted into liquid. Okay. And in this concept of condensation, if you take, if you want to take an example like take a bottle in which we fill up the bottle with cooling water or cold water, and if you see the surface of this bottle, you may observe small droplets on the surface of bottle. A small water droplets will be formed on the surface of bottle. Why? Because this happened, these droplets are nothing but saturated vapor pressure. Saturated vapor which is already present in air. This saturated vapor will be called as humidity. So what is meant by humidity? Humidity is nothing but the amount of saturated water vapor which is presented at that location. So this saturated water vapor has some energy. They have certain amount of energy. That means the water droplets in the vapor will have certain amount of energy. Okay, right? Whenever these droplets come in contact with cold water, they will transfer that heat energy. The droplets will transfer the heat energy to the water which is inside the given bottle. So this process is basically warming process. Condensation is a warming process, and if you take evaporation is quite opposite to it, known as cooling process. That means in this cooling process of evaporation, the internal energy will be reduced. Internal energy will be reduced in evaporation process, and the internal energy will be increased in condensation process. Okay, so okay, if we move on to the next topic we will deal about what is meant by boiling, a process of boiling. At ordinary temperature and pressure should be equal to 1 atmosphere. Pressure should be equal to 1 atmosphere. The boiling is the process in which the liquid state will be converted into gas state at a particular temperature. Boiling point at a particular temperature known as boiling point. So at ordinary conditions, STP condition known as STP known as standard temperature pressure conditions, the boiling point of water is 100 degrees Celsius. It means that at 100 degrees Celsius, the given amount of water will be perfectly converted into gas. So it is known as boiling process, and we will see the mechanism of how does the boiling starts and how does the boiling process will end. And the factor here is the pressure. How does the pressure can control the boiling process? We will see about this in our class. Deal about the concept of melting. So basically, melting means it is the phenomena in which a solid will be converted into liquid at a proper temperature. At a proper or at a fixed temperature. It is known as melting. If you take water or ice has a melting point as 0 degrees Celsius. It means that at 0 degrees Celsius, ice will be converted into water. So that is about melting. Next topic we will deal about freezing. So freezing means it is the phenomena which is quite opposite to melting. In this phenomena, liquid will be converted into solid at a particular temperature, at a fixed temperature. Again, here water, if you take water, water will be converted into ice cubes or ice at which temperature? Exactly at 0 degrees Celsius. Okay, so that is about freezing. And one more state is there known as sublimation. And in this process of sublimation, the solid will be directly converted into gas. There is no liquid state. And final topic of this lesson is we will deal about peculiar behavior or odd behavior of water. What is this behavior? Generally we know, and this is one of the reason why does ice floats on water. Generally we know every liquid will contracts on cooling, right, and expands on heating, every body also. But water has this peculiar behavior known as odd behavior or anomalous behavior of water. It means that within the range known as the temperature range is from 0 to 4 or 4 to 0. In this range of temperature, instead of ice cooling, contracting, it will expands, okay, and vice versa. Because of this, the bottle will breaks. If you take a bottle and completely fill the bottle with water, and when you keep this water in a deep fridge, after 1 hour or 2 hours, if you take it outside, you may see some cracklings on the bottle. Why? Because this is because of peculiar behavior of water. Deal about like specific heat capacity, we have another topic known as latent heat actually. Latent heat represented by capital L. What is this concept of latent heat? Let us see. The concept of melting, if you see, whenever you take some ice cubes like this, these are some ice cubes which are taken in a beaker, and if if you insert a thermometer here, and keep a flame below the beaker, what can you observe? The temperature will gradually increases up to 0 degrees centigrade. Up to 0 degrees centigrade, the temperature is gradually increasing. It means that the temperature of ice cubes are increasing. But if you see at 0 degrees centigrade, whenever the ice cubes are, the thermometer records 0 degrees centigrade, even though you provide more and more amount of heat, the temperature will not rise here. Why? Because where does all the amount of heat that you are providing here will go? This heat will be utilized to break bonds of H2O. In water, there is a bonding known as hydrogen bonding. So these bondings will be broken with the help of the heat that you provided here. Okay. So the amount of heat that is required to break break the bondings between water H2O such that the solid state will be perfectly converted into liquid state. Here solid state means ice. Ice is converted into liquid means water. This happen at a particular temperature known as 0 degrees centigrade, and the amount of heat utilized here will be called as concept latent heat of fusion, and the formula is like Q is equal to ml. Q represents the amount or quantity of heat that is required to change the state from solid to liquid. M is known as the mass of ice cubes, and L is nothing but our concept, which is nothing but latent heat. So latent heat is constant here. So in terms of latent heat, if you want to write the formula, you can write the formula as L equal to Q by M. So it could be defined as latent heat is nothing but the amount of heat provided for a unit mass such that its state is changed from solid to liquid. So just now we have dealt about Q is equal to ml. So fusion latent heat of, so L could be written as L equal to Q by M. So it is latent heat of fusion. So how to define latent heat of fusion? It is the amount of heat required to change unit mass of solid to liquid state at constant temperature. So for latent heat of fusion, constant temperature is 0 degrees centigrade. So at 0 degrees centigrade, the given amount of solid will be converted into liquid without any rise in temperature. Similarly, we have another quantity known as, and the value of latent heat of fusion is LF equal to 80 calories per gram. Very simple, the units are, if you see from the formula, Q means heat, so calories are the CS units. For mass, the units are grams. So calorie per gram is the unit, and 80 is the nothing but the magnitude of latent heat of fusion. Next topic, this is latent heat of vaporization. But actually it is not vaporization, it is the concept related to boiling. So in the process of boiling, if you see, the boiling is a phenomena in which the liquid or the water state or liquid state will be converted into gaseous state. And this entire phenomena for water will be taking place at 100 degrees centigrade, which means that if you take a beaker of water, let it be burning on a flame like this. We have taken certain quantity of water here of mass m. You may see at whenever the temperature, if you keep a thermometer, whenever the heat is keep on coming out of it, the temperature of the water will be gradually increasing until it attains 100 degrees centigrade. So at 100 degrees centigrade, no more heat will be utilized to rise the temperature, and the temperature is fixed here. The amount of heat that you provided here will be utilized to change the state from liquid to gas state. So the amount of heat will be treated as latent heat. So same formula as that of latent heat of fusion. Q is equal to ml and L is equal to Q by M. In this condition, L could be called by the name of latent heat of vaporization. How to define it? It is the amount of heat required to change the state of unit mass of a liquid to gas state at a constant temperature. So these temperatures are, in this condition, previously if you see, latent heat of fusion happens at 0 degrees centigrade and latent heat of vaporization happens at 100 degrees centigrade. These are not a fixed values. By changing the pressure, you can change these values. Okay.